Looks like we're all set there. All right. All right, so this is going to focus on the Desmos graphing calculator in North Carolina. That bit.ly there will take you to our agenda, a more detailed agenda, as well as some resources. It will be on the slides throughout, and Beth's going to be dropping it in the chat, so you'll definitely be able to get that from her. And runs through what we're doing, as well as some links that I'm going to continue to reference, and you can come back to, because things activities that you might run and set up with your classes or create your own. But with the graphing calculator too, once you have that account, you can save graphs, and I actually shared one that we might have time to look at later through in here for us. So that's a graph I saved through my account that you could access.
Nolan, if we can pause there, we have our first question related to the account. Are students able, when students log in with their account, are they able to save their works?
Yes, so they can save their graphs. So they would be going through, we're going to talk about the different calculators to access, but if they're going to just the general calculator, not that specific North Carolina testing one, they have access to logging into their account and saving graphs. And I can show you where those would appear for them.
Awesome.
Yep. So that leads right into, again, like how do we get to the calculators first? So if we go to desmos.com, we can go under math tools, and there's all of our calculators that are available to us. And so we could open up, do that in another tab, that general calculator. And you can see, just to kind of address what we were just talking about, my name up here. So I've already logged in. So I'm logged in, and I can go over here to this menu over here on the left-hand side, and I can see different graphs that I've saved. So if I pull one up, I can open that graph, and I can just share this URL now, which is specific to this graph I saved. So I could go ahead and just copy and paste it, or there's even over here, share your graph. You can copy and paste it from here. A way to get a printer-friendly version. We could export an image and also embed. So those are some options. Again, when you have that account and you're logged in, students could do the same thing. If they have to do is tie it to an email. So that's accessing the general calculator. But what we want to get to is the North Carolina version specifically. So I'm going to go under resources and assessments. And then I can click on North Carolina, and that's what's going to give me everything I need specific to what's available for you all in your tests. I also have these direct links in the agenda. So right here, the general graphing calculator is linked, as well as some support getting started. So that's where I'd recommend kind of going next if you're just starting out. And then this will take you to the screen I just showed you right here. We can open up this PDF, which will show you all the differences between the standard calculator and then the testing calculator. So a lot of these things you won't, or students really aren't going to notice aren't there. The biggest things are the keypad's going to be a little bit different. It's going to be alphabetical in the testing version. What's going to be helpful is the default angle mode will be degrees, right? So instead of radians, I can show you that in a little bit. And we'll talk about this plotting single variable implicit equations. That's disabled. It's going to force log mode regressions, which is just what if you were using the TI, it's a couple different ways you can do regressions. So it's the way the TI calculator would have done regressions. So it's going to automatically do that. And then some of these other kind of more complex features that really students aren't going to even notice are there are disabled. So that PDF gives you, again, that overview. And then we can get into the actual testing calculator, that version, by clicking on that link. So you'll notice here, I can no longer save graphs, right? So when they're in the testing version, they can't save anything. And I know I'm in the testing version, it's North Carolina, grade 8, Math 1 and above, compared to when I'm looking at the calculator here. Go ahead and clear everything out there. Where you have the black at the top and all those extra kind of features at the top.
And Nolan, this takes us to our next question.
Okay.
So some folks have noticed that if you try to, for example, enter in a quadratic equation and set it equal to 0, you can do that in the regular Desmos, but you cannot do that in the North Carolina Desmos.
Right. So yeah, so that's what we're getting at when it says we cannot plot single variable implicit equations. So there's no second variable there. But we could graph that as, and I had an example later coming up, which we'll see again, but we can plot, something like, let's just do -3, like this. Okay, so we'll graph it and we could still be talking about those x-intercepts. It will graph it also too if we don't put the y equals. So we'll graph it as if it is a 2 variable. So that's how we could still get that graph But once we put in equals something, that becomes, in this case, you can see it worked. It's really graphing the solutions automatically here. So it's really graphing like X equals those two solutions, those vertical lines, at where the solutions will be. So when you get to the testing version, that is not going to work, but the other versions would. So something
And
like this.
so your students are able to graph the quadratics. It's
Right.
just that you cannot set them equal to 0. We're wanting students to make the connection that we're looking here at the roots or the zeros as opposed to just graphing the solutions. And the reason that that is disabled, we try to make sure that no student is advantaged or disadvantaged by the calculator that they have. We try to keep the capabilities pretty similar. We still have a handful of students statewide who, for whatever reason, cannot access our online testing system. And if they can't access the online testing system, then they aren't using Desmos, they're using a handheld. And that is why that is disabled. However, kids can graph quadratics on the North Carolina version. It's just you have to either leave it without the y equals or you put the y equals. You can't put equals 0. Someone privately in the chat has said, or you could just have them use a second line that is y equals 0.
Yep. Yeah. So there's two ways to make sure they're still looking at it.
Right. So a couple ways to get around, and that now we're current on questions. So I will.
Great. Yeah, and I think it's valuable too because there's a lot more meaning and a meaningful discussion and understanding that comes from this graph versus just looking at, oh, these are the solutions, right? So I think that's great that we're going to kind of force students to make, see that parabola, talk about, okay, well, why can we do the two different ones, right? We're basically creating a system of equations from that. So a lot more meaningful discussion comes from what they're seeing here versus maybe through the general calculator. All right, so we've talked about kind of accessing it. I also put a link here for the testing application. So that will take you to that North Carolina version that they can use. And then here, this is where you can open up an actual released, not full test, but I guess the released questions. And you could look and get your students used to what that's going to look like when they're actually taking the test. So I would have to jump ahead to the calculator section. A lot of next, but here we go. Now we can pull it up and, before students are testing and they're in that actual test day, they can get a feel for using it within the format here and being able to resize a little bit, get used to what that's going to look like for them. All right, so I want to do just a few of the basics of the calculator and kind of an overview. And so I want to think about first, before I jump in, what do we want a graphing calculator to do? So the basic tools, we want to be able to, graph and change window settings. So how do we navigate that window? How do we zoom in, zoom out, and find things on the graph that maybe aren't in that standard window setting? We want to do basic calculations. We want to plot points and tables and graph equations and functions. And then where Desmos comes in with kind of some of these next level advantages is it's going to be really simple to do a lot of these things. We can also make our graphs dynamic. They don't have to remain static. We can also create some, what's kind of, we like to call a mathematical sandbox. So something for students to play around with, right? If it's dynamic, they can start to see, some animation. They can see some quick changes. When everything's on one screen, as far as the algebraic representation, the numerical and the graphical, as they change something in the equation, they're going to instantly see how that affects the graph. So they're going to be able to start connecting representations on their own. It's going to give us some great visuals to have some classroom discourse and discuss the concepts on a deeper level, make sure they're understanding them. And it provides feedback. Okay, so they're able to see things visually, and we'll talk about how we can use it for feedback as well. So instead of just saying like, hey, here's how you graph a point, here's how you graph an equation, what I wanted to do is just give some context. So kind of do a math task and then see those things through the math task to maybe make it a little more exciting than just a basic how-to. So this would be something maybe I could use in class, and I just threw up a picture to start class. What do you notice? What do you wonder? It doesn't even have to be mathematical, right? So kids might notice all kinds of things like the Twinkies, and they might wonder how old those Twinkies are. They might notice the remote control. What are they watching? They might notice that there's a can of apple juice that's missing, right? They might notice that it is apple juice. The price for 6. And so we just keep kids get that discussion going, get kids involved and engaged and invested in what we're talking about. No one's having to do any math yet. We're not restricting students' entry into this problem. And so eventually what I'm going to do is I'm going to pose the question, well, they probably won't let me do this, but what if I just want to buy 5 of these cans? What should they charge me? What should I have to pay? So that's going to be kind of our question we're going to work with. And lots of ways we could have students work through it, but one way is we could use our Desmos graphing calculator to visualize some of the stuff that's going on here. So go ahead and work within here. I'm going to go ahead and clear everything out. So that gear up here is that's my edit list where I can delete all. I'll go ahead and work within North Carolina one. So I can delete lines one at a time, but I can also hit that gear at any point and clear my calculator out. So when we look at our task, we've got some data. So let's plot the data we have. We know how much 6 cans cost. So I can go here and I can plot a point 6, comma 329. Okay, so I've got my point. That's plotted. How do I plot it? I don't have to go anywhere different in my menu. I can just click over here and I just type in the coordinate pair. So it's lovely. I can pull up my keypad here. So I could be using and clicking on those values. I've been using just my keyboard, which is a little bit quicker for me. We also have a list of functions here. So that's really the biggest menu they have to go to and navigate, which is nice. And all of those are just scrollable as we go from top to bottom here, different functions that they might use. So we got 1 point. And before we go back to 5, let's go forward to start seeing a pattern. So I might want to plot another point of, actually I'm going to type it on the same line. If I want to type it in the same line, I'm going to find 12 cans. I can do that. And then, so what I might need to do is 329 times 2, come down, do a calculation, right? I can do it all on the same screen. I don't have to navigate back and forth, which is really nice. I could go back and forth and toggle to that fraction form. So that fraction toggle button, convert to fraction, convert to decimal, back and forth, pops up as I enter that in. Since the context here is money, we're going to keep that 658. You notice it hasn't plotted this point, so I'm going to hover over this error messages. I can't multiply by points. It thinks I'm trying to multiply these, so I just need to make sure I put a comma there. I can't see that point, so I can quickly zoom out, right? I can do a quick. If I get too far, I can hit that home view. I can also click and drag, almost like I'm sliding the piece of paper. So I love that. Just kind of, let's just focus on that first quadrant there. So I've got that point. I might want another point, so I'm just going to come down here. I don't even need to start a new line. I'll do times 3. So now we're up to 18 cans and what that's going to cost. And the other way I can put these points in is I could have created a table. So to add a table, I can hit this plus sign over here. And it puts in the expression list now a table. So notice I've got points plotted with coordinates. I've got calculations over here. I've got a table and it's popping up over here in my graph. So everything's on that one screen. So I can just start typing in 329. I'm just going to click or hit enter and I can get more rows. And if you'll notice as I do that, a little magnifying glass came up over in the corner here. So that's going to be like my zoom fit. So now it will automatically set my window because I've put them in a table to those points. Okay. So plotting points, we can do them in the same line. We could have done separate lines, just writing the coordinates. We could put them in a table. We could also have converted this to a table. So if I hit this gear, this is where I deleted everything, but I also have the option for here to convert this to a table. And it puts it in a table for me. So if I get rid of this one, there's my red points still showing up over here. I can click on my points and see the coordinates in case I forget. So you can go back there. And so now we've got a little bit of a pattern here. So it looks pretty linear. So now I'm going to try to match the equation. There's y equals x. That's too steep, right? So if I do 2x, ooh, that's going the wrong way, right? So I love that it's updating on every keystroke. I'm able to make that connection between the equation and the graph. So let's do 0.5. Oh, that's too far below. 0.6 is above. I can quickly kind of just trial and error it until I get that y equals 0.55x. All right, so now I'm going to come back to that question. So my question was how much for 5? So I may need a reminder of what my x's and y's were too. So this wrench up here for my graph settings, I can set different labels, different minimums and maxes for my x and y axis. I can hide them, and I can change the step, but I can also label. So this might be a reminder in this problem that on the x-axis is not our cost. The x-axis, right, is number of cans, and the y-axis is our cost in dollars. So we've got that nice reminder here on our graph, that nice visual. And we wanted to know what the cost was for 5 cans. So here's my reminder that x is cans. So I'm just going to come down here and say x equals 5. And then I can click this intersection point. I don't have to go navigating a bunch of menus like you might in a handheld calculator. That's the key point I want. It's already kind of highlighted for me. I just click on it. I get that value. So we're not wasting time and memory and brain power with keystrokes. We can focus on the significance of that point and what is the meaning behind that point, right? What is that x-axis, right? That 5 cans. What is the 2.75? That's the cost. Okay, we could work our way down and talk about a unit rate. We could make then the connection as we click on that unit rate and the equation, that slope, right, or that rate of change, right? So there's lots of conversation. We talk about discourse conversations that we can have with this visual here and all the different representations on that page. We kind of played around with the equation, just a trial and error typing things in. We could run a straight regression. So to run a regression, we can just type in, we see that this is linear, so y equals mx plus b. And then we've got to make 2 changes to that. We've got to reference actually our table. So I'm going to go ahead and make this x1, y1, which usually defaults to, except I had converted this one to a table. But I'm going to reference this as x1 and y1. So down here, I can reference it as y1 and x1. So I can connect the table to this equation here. Now I've still got an error message because for regressions, usually we're trying to find that approximate equation. So instead of an equal sign, we're going to replace that with the tilde, which is on your keyboard, and it's also on this keypad here. If I go to the alphabetical keypad, and I can pop in the tilde, and now it gives me my slope and my y-intercept there. And it graphs the line for me as well. All right, so kind of a quick overview we changed our graph and window settings, right? We're able to zoom in and out pretty quickly, slide our graph paper around to fit to that first quadrant. That when we had a table, there was also the magnifying glass that popped up to do our zoom fit, which was nice. We did our calculations on that same page as where we were plotting points and creating tables. We graphed equations and functions all on that same graph there. That plus sign, we could add a new item. That's where we added the table. We're putting our math here. And that wrench in the upper right-hand corner is where we had some set graph settings. We were able to even label our X and Y axis. One thing I didn't show you, but we can edit a point, so I'll plot a point, or an equation, or even a table. So we can have different options. We can pull those up 2 ways. I can click and hold on any of these 3 dots. So if I click and hold, eventually this pops up. So I can have different style options, different color options. I can label and change the location of the label. And I could also make this a draggable point. So all of a sudden it's a dynamic graph where I'm clicking and dragging it. You can do the same thing if I click and hold on a table, that dot here, right? So similar options. I could even, since I have more than one, I could connect it with a line, different styles. And then the equation as well, I can click and hold, change the style, the color. This will make it thicker, I believe. Yeah, so I put it like 10, you can see it's starting to get thicker, and maybe we don't want it to be as dark, so we can change that there. You can also get to that by hitting this gear, the edit list, and then clicking the dot. So I was just clicking and holding, or I hit the gear first, and then I can pull up that menu. That was the same menu where we had the convert to table option that popped up and the delete all option. So that gear gets you into that mode and those options. And then I'll point your direction to, it won't be in the North Carolina version, but in the general graphing calculator, there's the help menu up here. So you can directly email our support team. They're super responsive. Even if you think it's a silly, small question, please don't hesitate to email. They'll answer it pretty quickly. The Help Center, which I've also linked, is a great place to go. I'm actually going to click on that because you can just start searching whatever you need. Click down here, Graphing Calculator, and you can see all the different getting started, calculator features, I mean, all kinds of stuff that you can explore. It's organized, I think, in a nice, easy way to find what you need, or just do that general search. There's also video tutorials, so just short clips that can help you get started. And the Desmos user guide is another great spot. I've even had student or teachers that will print this out. It's nice to have that paper copy, maybe just to kind of get your hands on and flip through a lot of the basics as an overview. All right, so I'm going to pause here real quick and then go through kind of a few questions that just show some of the features that students might use as they're taking the test. So gone through some basics just in general. But before I jump into that, I'll check in with Beth to see if we have any questions.
We just have one question. Is there a way, when you had the chart a moment ago, or when you had the table a moment ago with the values for the apple juices, is there a way to have the decimals change to a fraction without having to retype them on a new line?
Within the table, I don't know a way that you can convert them to the fractions there. You would have to go, I think, to another line and type them in, and then get that convert to fraction form button.
Okay. All right, that's all we have right now.
All right, great. So again, I just pulled a few questions just to kind of think about how students might be using this on questions as they're testing. One thing to think about is when we had that quadratic, right, that was a one variable implicit, but here we have two variables. So we don't have to worry about getting y equals to graph this. Our students can go directly into that testing version and graph that equation. And it was what, 4x plus 3y equals 9. So it's not going to be picky about that form there. And then there was a point, right? We can go to the same screen. So it's going to be real easy for students to get a visual of what's set up in this problem. And then again, they can focus on what's the concept, the perpendicular line. So then they could even come through and graph those options, right? 3x minus 4y, and really take a visual approach to the question, which might be easier. So now maybe they're going to count those slopes instead of manipulating the equation, the algebraic symbols to get the slopes. They can use the graphical they can lean on that graphical representation when they're testing, which a lot of times is easier for students. And then this was what we kind of talked about. I was going to show in here that if we type the equation as is, it's not going to graph in the testing version. So just one more time to reiterate that. That is a big difference, one of the big differences between the main calculator, right? So when we put this in as it is given to us, we're going to get that error message, but we can always get 0 on one side and then not type that in. So it would be, I think, 48. And then we can get our picture and still talk about our solutions and our x-intercepts and our roots and our zeros and all that good stuff that you might be talking about with your students. Same idea here. In function notation, it will graph it with the function notation. So we can talk about what the zeros are in this case, those x-intercepts, when we can graph it as m of x, it will recognize that. So that's not going to throw students off. They're not going to get an error message. It's going to work. And then they can focus again where they need to. The concept of zeros, they're focused on that piece of it, not necessarily making the tool work here. So it will graph if you put m of x equals, it will graph if you put y equals, and if you don't put anything at all, it will still graph that for you. Just to reiterate that with the systems, right? So that they could get that graphical representations directly by typing in the equation as it's formatted, as it's given to them in the question, and look for those x-intercepts, focusing on the concept of solutions and one solution, no solution, connecting that to points of intersection. And again, maybe, sure, do I want my students to be able to solve for y? But the only reason I had students do that in the past was because that's what the graphing, the handheld calculator needed it to do. So not necessary here. Another one where you could plot each of these, I won't put them in, but just wanted to iterate that you can put in the function notation so students can graph each of these separately, and then looking for that point of intersection, where are those equal? What's the y value when they're equal to? So again, they can focus on reading carefully that they're looking for the y value here, and not spending so much time and energy on the calculator. Function notation again, so if we want to put in g of x equals 19 plus 1.74x, they want to know what g of 30 is. Right, we can come down here and we can use that notation and come up with that value as well. Here we could convert this, right? So again, if you type this as is, it's not going to graph, but we could create a system from this. So kind of what we were saying earlier, someone threw in the chat, if we were graphing, y equals 0 on one side and y equals the quadratic on the other side, you could do y equals the left side, y equals the right side, and basically transform that into a system of equations to help you get those solutions. Here's a question with average. So there is, I wanted you to make sure you're aware of a mean function. So under that keypad, we're going to scroll not too far. It's right there. We can pull up mean. Oh, it came in that line that already had something. And then you can just type in the values with commas and it's going to calculate that mean for you. You can also just type in the letters. So as I type it in, it's not recognizing it until I put in the N, and then I have to type in the parentheses. So just a little bit quicker if we know what we're doing to calculate mean. Median as well, so that's also an option. So we just go to that same spot, or you can type it in median, right? Right, it will calculate that median, and we can add values pretty quickly. So maybe we're testing different values that are different answer choices. We can do that fairly simple. Here we've got some one variable data. So there's a couple options we could kind of look at. So the frequency is just on here once, but one thing we can do is we could plot those in a dot plot. So I'm gonna clear that out. So if I go to functions and I go to visualization, so I could do a histogram, a dot plot. I'm gonna go ahead and do dot plot. And then what we need to do is we need to create a list. So we do need the square brackets within that. And then we could put in the different values that were down there. So let me look back, right? That first one was 15, 25, 35, 5, 5, 15. And I do get that zoom fit, right? And so I could kind of see where the data is skewed. And match those up as I put in the different data sets. So they're just plotting the points. It's a frequency of 1. I thought that would be a good one way that students might visualize those. Another one that's kind of a funky form, but we'll graph it, right? So we can clear that out. If we type in our equation of a circle, we can get that visual. hit that home screen. So you could see my because of the last data that I had in there, it was kind of funky. So I hit that home screen, take me back to that standard window. And then we could think about what we're asked here about the radius and try to count that radius there, that nice visual. Another one, so this is where I can make use of sliders, which I'm going to come back to for the instructional piece in just a second, but we can type in this equation and start to put in different values quickly for K and see what kind of effect it's going to have on the graph. So if I go back to my graph and I just type in K times X minus 2 to the 4th, oops, I need an exponent. That's what I'm trying to do. It's going to prompt me. It doesn't recognize K as like my input or output, my X or Y or that function notation. So it asks me if I want to add a slider. And then the problem, they said K is going to be positive. So I'm going to go ahead and click right here. Instead of going into -10, I'm going to start at 1. And then we can go to 10. We could go further than 10. And if we wanted to change the step, we could do that. And then I click outside of it. So again, if I want to click or change this, I can click on those numbers, change it, and then just click outside of it. And now you can start to see the effect it has as it changes, as it goes down, as it goes up. I can even go hands-free, right? We could speed it up, some options to play with. We could make it, instead of go back and forth, just kind of once it gets to the end, it cycles back to the beginning. But that's a slider there that could be helpful even for students to visualize in that specific question. We did regression earlier, so this would be a question where we would want to look at that regression. And again, if you need to go back and look at those step-by-step, that help.desmos.com, I think I got rid of it. Nope, there it is. You could just search regression. And there's a little video to walk you through it as far as some other notes down here. All right, I'm gonna check in with Beth real quick, see what questions we have.
We don't have questions. We have tremendous excitement about the sliders.
Oh, yes. We can do some more with that in just a second.
Yes. The only thing we had, and it's very minor, is can you show about dragging the graph to change your windows?
Sure. Yeah. So changing the window, it's kind of hard to see because we're virtual here, but I just have my mouse and I'm hovering right here. And all of a sudden I'm going to click and I am holding down my mouse button. As I hold it down and now move my cursor, I can just slide that. So I'm clicking and holding and then moving it around. And then these are just my zoom buttons here. So that's how I'm doing that. It's a little hard for you all to see. Okay. So yeah, getting into, you mentioned sliders. Sliders is what sold me like over, it's been almost like 10 years that I've been using Desmos, but literally that was what I saw someone use in Desmos and I'm like, I'm using that because it's so simple, but it's so powerful for students to see and make those connections between the equation and the graph. So when we think about using Desmos instructionally, this is where I get super excited. So we want to enhance that student engagement and learning. We want students to predict. We're going to invite students to just observe, like their informal observations before we get into the formal stuff. Like, what do you see? Any student can answer that question. Like, what do you see going on in the graph? Noticing those patterns, and then we come in and we help them build that structure, that more formal notation and formal vocab as we go through. And again, it comes back to a lot of students doing the connecting between those representations. So what does that look like instructionally? So one thing I like to do is introduce the concept with technology, remove the technology so students still need to be able to do it by hand, right? They need to know how to do that computations and manipulations of the symbols, and then bring it back to confirm their answers and check, like that feedback piece. So one example of that is function notation. So if I'm introducing function notation, I'm gonna come into class and I might just say, look, here's the line, y equals x plus 3. Today we're gonna learn another way to write that with function notation. This is what it looks like. So right off the bat, we can see, they don't have to take my word for it, right? They can see if as I click that on and off, those lines are right on top of each other, right? I just see the red, as soon as I graph the blue, it pops back up, as showing there. So these mean the same thing, okay? So we're establishing that they have a nice visual to back that up and not just take my word for it. And then I might just start typing in things like this: f of 1, f of 2, f of 3, f of 4. Step back and just ask them, what do you notice? What do you wonder? Um, what patterns do you see? And so students might notice, oh, well, you were going up by 1 here, and it goes up by 1 over here. And then I might direct them to, okay, well, can you connected it vertically? Can you make a connection of what's going on horizontally between these numbers, right? And they might notice, oh, +3, +3, +3. Oh, where do you see that, right? Oh, up here. And, eventually we have this discussion and we get to the point where students are telling me that this is what we're plugging in and this is what we're getting out of the function, right? Our input, our output, our X, or Y. And we might even, before we get there, I kind of like to play the game, like, and kind of keep it a secret. So like I ask a student, like, okay, if you think you know what's going to happen, tell me, predict what's going to happen when I put 80 here, right? And before I type it in, right, they make their prediction. Or I might tell them to come up with their own. Give me a number here and tell me what the number is going to be here. So it kind of like a little game there where they can kind of confirm themselves. It's not even me giving them that feedback. Like if they're able to make that prediction accurately, then they know they've got it. So just a fun way to kind of introduce that function notation and what's going on. And then let's bring in the other representation, right? Let's bring back the graph. So we were talking about these as inputs and outputs. Well, what's another way to represent an input and output? Well, we can pair them together, right? So we're starting to use that language as we discuss with our students and get them comfortable with the vocabulary. Oh, and I typed that in wrong. So I can see visually, right? There's a great, I did that on purpose, right? So that we can see visually that something's off here. It's not on the line. We want students to see that those points, right? These pairs of numbers are going to be all the ones that are on the line. They start to populate on the line as I type them in. So 3 and 6 need to be paired together. They're paired together by the rule or the equation, and they're paired together along that line. And then we could talk about the in-between points too. We can talk about how there's an infinite amount of possibilities, and we're having this really rich, deep conversation that's incorporating all the representations of this function. And all because we're just talking about function notation. So like I said, that's one progression I love to use. Again, they can come back to it, right? They're still going to have to, I still want my students to be able, when I ask them, if I give them an equation like this and I want them to find f of 3, go do it by hand. But hey, come here and check it yourself. Check it graphically. Check it, plot the point, right? If that point is on the line, right, then that's a pair that works. That's a pair that is part of our function. It gives them a little more independence too as they're working through it. And it's not going to replace, right, that algebraic piece of it or that doing it by hand piece of it. All right, I mentioned sliders. So an example of how we can really use sliders is I had the other day, this came up within a problem in Algebra 2, right? So some students are telling me it's this. Some students are telling me it's this. So we say, okay, who's right, who's wrong? We start to have a debate. And hopefully we get to the point where one student says, well, a squared means this. A to the third means we're multiplying it 3 times. So there's a total of 5, so it must be that, right? So good conversation. Let's just give them one more representation to really hit home that they're equivalent. So I'm going to add that slider for A. And now all of a sudden, I can get the value of these expressions for different values of A. And we can see that no matter what A is, which of these are equivalent. So now we're having this deep understanding first of what's a variable, right? A variable just means we're plugging in any number we want here. What do we mean by equivalent expressions when we're simplifying or we're manipulating these symbols? We lose track of what we're doing. We're just maintaining equivalence, right? They have the same value no matter what the variable's value may be. So you can do that type of thing for combining like terms, right? So just A plus A versus A times A, two things that, students mix up. Which one of those is 2A? Which one of those is A squared? We can have that conversation about equivalence again. It's the basis of trig identities, right? So, why does sine of, remember this, right? Sine of 2A is the same as 2 sine A cosine A. Got an error message here. Use parentheses around the sign. Okay, so yeah, I've got to close that. And we can see that those are equivalent. Right, so just another way to emphasize those types of things. Another thing instructionally, so maybe I'm teaching one variable inequalities. So it will graph this, right? And I don't want students to rely on this, but I can use it to support. So again, my expectations are we're solving this by hand. Like students are going to go and they're going to do it by hand. And then they're gonna see maybe whether they're right or wrong and confirm it. And we can go even further is they can find which line they made a mistake. So maybe they got this problem wrong. They can come back on their own and they can say, okay, well, the first thing I'm gonna do is combine the like terms on the left side. Oh, and I know I did that correctly because this is still an equivalent inequality. And again, we're emphasizing that huge concept of equivalence, but we're also emphasizing it visually, which I had never thought about sometimes, like doing this until I started doing it within Desmos, right? So they've confirmed that they have kept things equivalent to the original problem. And then we can go to the next one. And so maybe, let's see, negative x minus 11 is 7. All of a sudden here, this visual is telling them this is the line where they made mistakes. So they're going to rely a little bit less on you. You've got 20, 30 kids in the room, like that could make 20 or 30 different mistakes on this one problem. So you can't get to everyone, but maybe they can narrow down to the line. Maybe their neighbor can even help them. Okay, well, what did I do wrong on this step? And they're starting to be a little more independent there. So we can see, let's see, maybe that was actually needed to add the 5x instead of subtract them. Still equivalent. And then I love, maybe I haven't even told them anything about what to do when you divide by a negative. So it changes how I present the material. It gets them to a point where there is a contradiction, right? And math does not like contradictions, right? Something's not right. This is no longer equivalent. And maybe that visual is enough for them to discover the rule. Like we need some sort of rule to keep this equivalent. Well, how do we keep this equivalent? And I had a student one time, they didn't flip the inequality. What they did though, well, they did just not in the way I was maybe thinking they were going to. They did this, right? And so what a great conversation we could then have about what does this mean? Is this the same thing as this? And we have that visual to back up all of these, right? So in order to maintain equivalence, we're going to have to flip that inequality symbol. We're going to have to flip what's on each side. We're going to have to flip what the greater side is and what the less than side is. And how much more powerful and meaningful is that to learn that rule instead of when you divide by a negative, I flipped the inequality because Mr. Doyle told me to do it, right? Like it's just much more powerful and impactful, I think, for students. All right, I'm getting short on time. I have so much I want to do. So what I'm going to do is go to my agenda real quick and then I'll check in on questions. But I did want to show you this Polygon tool because I thought this was pretty cool. And if I do have time, I'll show you lists. But so I saved this graph and this is linked in the agenda for you to pull up. But basically what I did was I created a table with the 3 points I wanted for a triangle. And I used this polygon function. So what this does is it's referencing these points here and it's connecting them. What the polygon tool does is it connects them. I'll turn them off. So right now, just the table's graphed, connects them and shades it in. And then what I did was I'm going to put another one right on top of it. But I'm actually going to keep it off and play the what if game. So I'm going to say to my students, what if I make this y negative here? And so we can do a think, pair, share. Students start kind of using their hands. It's going to go here, it's going to go here. And then we reveal it and they can see what happens. And then we can talk about what happens. Was it what we expected? Can someone explain why it's down here, right? And we can talk about these coordinates are all becoming negative. So they're going to be below the x-axis. All right, so what if, then I delete that, I come over here, put the negative here. Think, pair, share, students discuss, we have a discussion, they'll reveal, they're engaged, they want to know if they're right or wrong, and then we can talk about why, right, and have students explain why it looks like that. We can take it further, right, so we could put times 2 times 2, see what happens, what's happening to all the coordinates, right, numerically, what's happening graphically, the different representations. what happens when I make those 0.5. So just a fun, interactive, great way to have discussions around a really clear visual of those transformations. So again, this is not something students are going to do on a test. They're not going to create a table and use a polygon tool and probably go through all those steps, but I can do it instructionally with my students and display it in front of them. The other thing with sliders too, I'm going to squeeze this in, I really want to, is it's just, again, that visual where we get students to make observations. So if I'm introducing y equals mx plus b, they can observe and tell me what's happening, right? And in their own language, and we can eventually get to, right, the direction, the steepness is changing here, right? We're shifting it up or down, right? We're even click real quick, we can pause it and make a connection, right, to that value and that value here. So students are coming up with that connection. We're leading them there. We're providing them with that visual to do it. And you can do that with anything, right? So we could do that with, could do it with circles, right? So any transformations we want, and we can really see what's going on quickly and make those connections. We could do a sine one. Right, so we could turn that off, right? So any function we want with the transformations is pretty impactful there. All right, I didn't get the lists, but I think I hopefully gave you a good amount of just maybe hopefully inspiration to play around and see how you might provide these visuals for students to lead that discussion and lead your students to make those connections themselves. So I'm going to pause and check in on questions. And also while I'm answering those questions, as I mentioned before, there is a survey that's linked in our agenda, a couple spots down here, and then also at the top of the page. If you could just, it's only like 3 questions. Answer those questions as I answer your questions. And like I said, it's really helpful for Desmos because we want to continue to put out resources and have webinars and have different things that are really going to support you as you continue your journey beyond today. So if you could fill that out while I check in with Beth on questions.
All right, we have 4 questions.
Okay.
The first is there a way that you can have students graph inequalities like x is greater than -4, but on a number line, so one-dimensionally instead of 2?
There is not a quick way, yeah, so like it would show up with just the line. There is not a quick, easy way for that to be done by students, yeah.
Okay.
We can turn off the y-axis, I mean, and so we would still have the shading though, so that might not be what they're looking for.
All right, next question. Can you show again how you turned on polygon functions?
Yeah, so polygon is just, I can just type in polygon and then with the parentheses. And so I referenced the table. You could just start plotting. So let me get this inequality out of the way. I might come back to that because I might have something that's not too complicated that might work. And as I start putting in points, it will connect them and shade them in. And so I had just referenced the table, putting in the X1 and Y1. And you can again reference that. I put a link to that so you can explore it a little bit on your own too. But that polygon tool, whatever points are in those parentheses, it will connect. And let me just add to it so you can see. Right, we can add more points, more sides as we keep going.
All right, our last question is a for you and for me. Does Desmos do live visits to schools to do PD for the scientific and graphing calculators?
Yes, so you can, I mean, if they're interested, they can email me and I can forward that to the right people. You can also email that support@desmos.com to set that up as well.
All right, and then the part for me was, does DPI offer that? And we do not. We offer the webinars. It's a capacity issue for us. We aren't able with as many regions and schools and public school units. It's not something we can support and be fair about it. And with that, I don't see any other questions. So just
Okay.
a
real quick though. So
Yeah.
this isn't maybe the easiest way for students, but if you were trying to come up with, and it's still not going to give the endpoint, whether it's open or closed, clearly you have to kind of drag, but you could graph that horizontal line and then put the inequality here. Restricting, basically this is how you restrict the domain. And then I kind of turned my y-axis and my grid off, and then I made sure my x-axis was by 1. So I kind of created a number line through there. Again, that might not be a quick, easy way for students to do it, what they're looking for, but it is a way to maybe get that number line up there.
And that is why Nolan is a Desmos certified presenter, because he just did that on the fly. As we sign off today, I'm not seeing any other questions.
Okay.
A reminder that you will receive a recording of today's webinar along with all the links, and that will come out from NC Public Schools. Later today, you'll be able to share that with anyone that you would like to share it with. It will also have contact information for both me and for Nolan. We appreciate you spending your time with us today. We hope that you learned all kinds of new and fun things to try with your kids, and we hope you have a great week.
Thank you all.